So let's get started. So this is the DM plans and policies session. So just the obligatory reminder, it's been a long week, it's been a long day. We still all have to be nice to each other, even when we're all tired and so forth. So continue being nice to each other. Appreciate that. Reminders about the stickers, masks, social batteries, etc., as you've heard many times. We have virtual participants, including Leanne, who's going to be presenting. I think this room is particularly sensitive to like background noise, and it kind of swamps the Zoom audio. So best if people keep this quiet as they can.
This side of the room has microphones. Everything that's whispered here is heard. Over there, nobody hears anything.
Okay.
So anyone from over there who wants a question or who should speak should come to this side of the room to ask their question.
Okay, so this is the quiet side. This is the quiet side. That is the side where we will come ask you to repeat questions. And we have a Slack channel, and I believe Will is watching Slack, and I'll have Zoom open as well for hand raise. So, okay, this is the agenda of topics we're going to talk about, and I think I will hand it off to Leanne now.
Thank you, Colin. Okay, so we organized, Colin and I organized this session in response to a lot of questions that we've been getting coming in from the community. Things like, you know, what data products will be in the upcoming previews and releases, and could you make these different sort of coads for us, or how can we get GPUs on the science platform and things like this? And we sort of thought that, and the other big one actually that we'll address is, and this will really be the main topic of today's session, is how does the community provide feedback on the Rubin data releases? And so, as you know, we have a very fast turnaround time for data releases. You know, we process 1 year of data, we put data release X out, and we're immediately processing the data for data release X+1. And so what is that process then by which the community can work with the data release, you know, do some analyses, and then give some feedback back to data management? This could be anything from bugs to recommendations for improvements and so forth. And so there've been a lot of discussions and questions around this, and we thought we'd just organize this session to present our thinking on these ideas, but also really to get you know, discussion happening with the community. So we'll start. Yeah, so I'll start by just reminding everyone of the timescales for data releases. Bob showed this on Monday in his plenary. I'll just briefly recap again. We're expecting Rubin First Light in just under a year, so March to April 2025 next year. So we're really very close. And then Data Preview 1, we expect to be coming out shortly after that, April to May 2025, which is the first time that people from the community, or anyone, in fact, is going to be able to work with real LSST data. And so we're very keen to get this data and to run our system on it and to see how well our system performs on real LSST data. And we're putting these data previews out, both so that we can test our systems in advance of operations, but also so that the community can start to work with this data and our services that serve these data and give us feedback so that we can take that feedback into account in advance of operations. So then we'll go into operations around the middle of next year, roughly this time next year. Alert production will ramp up around the same time. Data Preview 2 will come out towards the end of next year, or the earlier the following year. And then Data Release 1, roughly about 6 months after that. So after Data Release 1, we then go on to roughly annual cadences with Data Release 2, 3, and so forth, right through to Data Release 11 in the survey. And so the focus today, as I've just said, is going to be on how can we work with the community to get feedback on these data releases so that we can make sure that each successive data release includes all those improvements. Okay, next slide. Okay, so we did put out a call for questions that people had, and this is just one question that I'll highlight that came in around that. There was a question about the imaging data release timeline. The question was, can you clarify if the 80-hour hold time on image data is still in effect at the start of operations? So the answer is absolutely yes. The 80-hour embargo on imaging data applies for the entirety of operations. And note that this embargo period is 30 days during the commissioning period. So in fact, the 80 days, it comes down to 80 days when we start operations, and it will not change. The only imaging data that will be available on a shorter than 80-hour timescale are the dear source postage stamps that come in the alert packets. There will be no user-driven cutouts available on embargoed images. So the cutout service that we've already deployed a first version of this cutout service. It's part of DP0. You can try it out on the Science platform at the moment on DP0 data. That cutout service, you won't be able to use that on images that are still embargoed. So if you request a cutout through the cutout service and you can get it, it means the image is out of embargo already. And yes, I think this question came in response to the fact that the DPDD hasn't been updated in a while, and it has not been updated yet to include soon. Colin, should we go forwards unless there are any questions?
Sure. We lost 1 second, so I might have missed your next slide, but.
Oh, sorry, that's okay. Okay, feedback on data products. Okay, next slide. Okay, so the primary route for feedback on data products is community.lsst.io. It's the basic, first level go-to destination for questions and emergent issues. There's a support category, and this is monitored daily by the Rubin community science team. And now that we're coming up close to Rubin operations, the community science team is a new team in operations, and they've been ramping up over the last 1 to 2 years, and they've been doing a lot of work with DP0. And so we do have people actively monitoring this forum to make sure that even if it's not them who answer the questions, somebody will answer the questions. We're expecting from this lots of feedback to come out in the forms of things like, why does X work this way? Or has anyone seen behavior Y before? Or is there a way to do Z? And these are the sort of questions that I think, having a big community be able to answer these can help answer common questions and create a really good knowledge base. I mean, obviously, there's going to be more in-depth questions and things that people won't have answers to. And the things that can't be answered by the community easily on the forum, the community science team will make sure that someone from the project comes in and answers some of the more difficult, harder questions. Yeah, I think that covers most of that. Colin? Great. So another route for feedback is the users committee. The Rubin users committee has been stood up already, and it is active. You can see at the bottom of this slide the list of everyone who's on the users committee already, who are very happy about hearing from the whole Rubin science community about their experiences. The users committee is charged with soliciting feedback from the community about the Rubin data products and the science platform. And the users committee will take those recommendations, and they will take that feedback from the community, and they will make recommendations to the Rubin operations director. And so this is a way of this is like a committee that's going to help us in terms of gathering all the feedback from the community, requests for changes, requests, say, for new algorithms, all sorts of things. And they will help us to prioritize, and they will help us to look at, what is the science gain from each, and how do we prioritize them, and what should and shouldn't we do, and importantly, on what timescales. There is a detailed charge already that you can have a look at. There is a website that you can consult. They have already produced reports mainly focusing on some of the experiences around Data Preview 0, and you can find those on the community forum. They are open. They have regular meetings. There's a contact email here, and there's also a Google form for you to provide feedback or suggestions or requests to the users committee. Next slide. So this week, it's been, even here in Zoom land, it's been very, very exciting, and we've heard lots of requests for additional data products to be produced. So just a bit of a summary of some of the things that we've been hearing this week. Requests for specialized COADs, for example, that apply conservative cuts to a single visit image, or perhaps COADs that will try to homogenize the depth to the extent possible across the sky for a given data release to support a particular type of science. We've also heard requests to produce alerts from nightly COADs. And we've also heard requests into how are we going to go about what's the process to integrate community developed packages into the pipelines, or perhaps, have a new algorithm, or even create a new data product. So add a new data product to the list of things that we might that we might produce. And this is just a sample of some. I'm sure there are many other things that people request, but these sorts of requests, we're starting to get more and more of these as the community have experience with Data Preview 0, and as people start to have experience with Data Preview 1 and 2, we're really expecting to get lots more of these sorts of requests. And we need a good process to collect all of these, to assess them, to understand the scientific gain, and then to do a technical feasibility study ourselves as to how much effort it would take to implement these things. And so these are examples of the sort of requests that would go to the users committee, who would then make recommendations to the operations director. And as I've said, we would then carry out technical feasibility studies, and that would be input to the director, who would then make a decision as to how we would, which of these we could implement on what time scale and so forth. Okay, next slide. Okay, so that covered data products, but we've also had a lot of requests around things like resources. And we also foresee in operations to put in place a resource allocation committee. And this allocation committee, it will be comprised of members from the science community as well as the project. But this is more focused on things like groups who want to, say, request additional storage or computational resources, either temporary or permanent, to do specific types of tasks. So for example, run some massive simulations or train classification algorithms or things like this. I mean, this could be anything from batch compute accounts at Slack or even additional compute cycles in the cloud. I remember Will presented earlier this week the hybrid model of having the data at Slack, the processing at Slack, but the users and the data products in the cloud. And so, extra compute cycles in the cloud might be for, detailed analyses that the community want to carry out on the data releases themselves. Related to that is, of course, we've also heard from people about adding compute from, say, another Google funded account to operate on the RSP. So this is, you've got your research funds and you want to bring credits to the data and supplement what we're able to provide you with additional credits. What's the process for that? We've also heard requests for hosting externally produced catalogs to support scientific analyses. So for example, an AGN catalog or cross-match catalogs or things like that. Things that aren't just necessarily, things that are quite big and you wouldn't want to put in your single user space, not just because they're big, but because also you might want to share them with a collaboration. So for example, take a science collaboration, the solar system science collaboration might have some software or catalogs that they want their whole collaboration, their whole science collaboration to be able to access. So these sorts of things require extra storage, and we have to, take the time to put them in there and host them and so forth. And GPUs, we're hearing a lot of GPUs to train machine learned algorithms. So requests for GPUs are also coming in as well. So we're getting lots and lots of requests here, and we need some way to assess these, to understand the scientific impact and the need across the community, and also to understand that the time it's going to take for us to put these in place and support them, and the cost of things like buying storage and compute cycles and what we can support. So this is the idea behind the Rubin, the Resource Allocation Committee, is to develop and implement a process for handling these sorts of requests. Broadly speaking, the Rubin Resource Allocation Committee will be analogous to the Time Allocation Committee, which allocates time on a telescope. This is going to sort of allocate extra resources, compute or storage, batch resources fit for users to work with. And so, as I've just mentioned, they would review the scientific justification and make recommendations to the operations director. We can then internally do a feasibility study and a cost analysis. And this can all then go into decisions about how we can start to support the community and some of their requests. Unlike the users committee, the RAC, I guess we'll call it that, has not been stood up yet, but we intend to start thinking now about standing this up before the start of the survey, so we can start to take in some of these community requests and analyze them. Okay, Colin? Okay, so just in summary, these routes to feedback that I've just introduced, they're open throughout the data release process, and we are always interested in feedback via any of these channels, or even if you've got feedback on producing a different channel for feedback, that would also be very interesting for us to hear about. Just to note that the data release process, it's an extremely tight and I would say aggressive processing release turnaround time as we go from data release 1 through to 11. And this can impose a lot of time constraints on how quickly the feedback we get from you can be incorporated. This is going to be challenging both, I think, for us, but it's also for the community, I think, when they want to get, you want to get bug fixes or new features or algorithms into data releases. And so in the second part of this session, now Colin's now going to go through how we do the data release processing and how we might start to think about incorporating feedback from the community. Okay, over to you, Colin.
Hey, thank you. So yes, exactly as Leanne was saying, we want to make sure that not just that you have the channels to get feedback to the project, but that you actually have the data that you need in order to make that kind of relevant, meaningful feedback that improves the science that you're able to do. And so that's what this is going to be about. So a little bit of background about data release processing. So in case anyone hasn't heard, we reprocess the entire data set every single year. So every data release is all the visits that we've ever taken have to go through the process. And because we have a 1-year timeline for producing these data releases, that is the maximum length of time it can take for us to produce that data release. And this is a nice diagram that Yusra made describing all of the steps that need to happen in that 1-year timeline from T-minus 12 months, where we've collected all the data. We say, okay, this is the last visit that's going to go into the release. And then over here on the right side, this is, okay, it goes out to the community. And you see that, like, we have the hardware to support getting this all done in about 9 months. We need a bit of time on the beginning and the end to prepare it both scientifically with some precursor runs and to prepare it for the users in the science platform. But basically that entire 9 months in the middle is spent churning data through on all the CPUs. And so we recognize, and we've heard feedback from the community already that really prompted the session, that this means that there's very little downtime where we're just like, the cores are sitting idle and we're waiting for your feedback on how the last production ran. By the time the data release goes out to the community, we're already kind of ramping up to start doing the next year. So you can think of this whole chart gets repeated again for the next data release. And so we're really jumping on it very soon after we release each data release.
A question, if I may?
Yeah.
Should we think of the amount of compute time required in year 1 and year 9, for example, to be very similar? I mean, imagine you're redoing all the alerts and everything. So some things are cumulative. Can you, how should we think about that?
Yeah, this is, Will.
So the compute model assumes there's a scaling to that.
Yeah.
And there's more computers bought each few years. So it's not the same amount of compute in year 1 as in year 10 to try and keep the time around about the same. As much as we can do that. It could be completely wrong, but we'll find out in year 2-ish, maybe.
When the data volume doubles, as opposed to increases by 10%?
Exactly. That's for me is the second year is the real killer. It's 100% increase.
Yeah, I had some thoughts on that I was going to put at the end, but just to give you a taste of that, since you brought it up already. It's true that we have this nominal plan. It's also true that the data is going to grow every year. It's also true that the computing is going to grow every year. It's also true that we'll get better at it. So like we expect to we will get better at it. It's also true that there's many different competing factors here. But just for broad brush planning purposes, we're sort of aiming for this whole year to be occupied. And I would love to make it smaller. We will absolutely be trying to make it faster if we can, but this is sort of the conservative way of estimating it. And so that means that in addition to not having a whole lot of time after the release is produced before we're already starting to produce the next one, it means that okay, if we're here at the release date, the software that was used to process those images comes from all the way back here. And so we've done another year of software development, improving algorithms, adding new things, adding new functionality, things that users might want to investigate. People might have strong feelings about how this one particular algorithm works. And if that has changed in the past year, then they don't have a data set to work with to kind of verify that we've done the right thing for their science. So that's just a big, complicated problem statement. The pitch here is that what we're starting to put plans in place for is to make this, think of this as a beta release, right? So at the very end of the production, you see there is this time where we are going to be pushing the data into QServe, pushing it into the science platform. We're not going to be busy doing a whole lot of processing. It's mostly going to be done. It's mostly going to be kind of putting the polish on things and making it available. That's time where we can use those cores to start using to start doing a small production, very small. We'll say that more about that in the next slide. That uses the latest and greatest code, and then we can make that little bit of data available for verifying that the version of the code that we're going to use for the next release meets your science needs. So this is like, the scale of this is not going to be large enough that we think people are going to want to do a whole bunch of science on that. We're going to put out this big data release instead. That's going to be the thing that we want people to go get their light curves, to go get their coads, to actually do their science. But we know there's experts who have strong stakes in this particular functionality, that particular functionality. And so we want to make sure that they have some way of kind of doing their testing on a common data set that enables them to provide feedback to the rest of the project. So that's the basic pitch for this beta release at the very end of the processing process.
Colin, can I?
Yeah.
That turquoise box includes the time to make the beta release and to get feedback on it?
So okay. So this is the time to make it. The details of when we actually need to incorporate that feedback are actually somewhat complicated. And I don't want to get too much specificity on that, because I think we will learn like when the deadlines for feedback are better as we rehearse this through the data previews and through the first data release. We're not going to be activating this type of beta until we've already gone through a data release. And so really what you're asking is, where in all of these steps do we need feedback from? And that's kind of a complicated question that I don't really want to get too deep into today.
So roughly speaking, is the code for this DRP run frozen at the left-hand edge of this block diagram?
We sort of progressively freeze the code. You need to freeze the code for single frame processing earlier, potentially take changes to coads later, but it also you don't want to be doing massive changes later. You want to kind of be on a convergent path. I think Francisco had a hand.
You mentioned that how is a small subset defined? Is it, let's say, 1% of the objects of all the batches, or 1% of the batches, or let's say, do you know what is a definition of the small subset?
The idea right now is 100 square degrees. I don't know if user wants to comment on comparing that to other data sets.
Yeah, okay, so the 100 square degrees is, so it is so we picked that because that is the pilot runs that we've done for the that NEOJ has done for the HSC data release, and was sufficient for assessing weak lensing quality of the data products. It was a contiguous 100 square degrees in all the bands, complete DRP pipeline, which includes the DIA branch of it. It is on the order of it's on the same order of magnitude as the DP 0.2 data release, which was 300 square degrees. Anywhere between 100 and 300 square degrees would be reasonable here, but that's like the order of magnitude of the data set size to keep in mind for this.
Yes, because I was thinking that sometimes you want like it's different to have a small percent of the sky than a small percent of all the sky. That's on the question you want to ask.
Yeah.
It's,
Yeah, we understand that different regions of the sky have different properties. We will try to pick something that is representative. This is still a few years away.
We've typically done contiguous pilot runs or small scale runs because our surveys have been kind of smaller in scale. That all changes when you have 20,000 square degrees. So they'll give us more flexibility. We'll have to exactly confirm that question. So yeah, this is mostly just summarizing some of those details. I think a good way to think of this is that this is kind of analogous to the way that we involve in-kind contributors in the commissioning process. This allows us to involve more of the community in the data release process when we're in the steady state operations era. And I will also, I think I mentioned this offhand, but like this only makes sense once we get into the kind of full year-long data release productions and have already had one completed. So we don't expect this to be started very soon. This is still probably at least 2 years before we would start making one of these beta releases. But we want people to know that like this type of functionality is going to be available, that we're not just going to leave everybody in the dark as far as the latest version of the pipelines code. I should also put a few caveats that the purpose of this is really pipelines testing. And so we expect this to be a kind of experts aimed functionality. So it's not necessarily going to be supported in all of the RSP services. If we can, we'll totally make that available. Like, why not if we can? But there might be cases where we just need to, like, RSP team is going to be busy in this time frame, and so we can't support that. Sorry, I missed one important thing. We also expect this to be available to all data rights holders. We're not going to run a sort of sub-selection or a criteria where you have to prove your pipeline's abilities. We'll just make this available to everybody. If you want to do testing on it, go for it. It'll be great. And we'll also talk more about, this is what Phil was talking about, the timeline for when that feedback needs to be incorporated. We'll know more about that once we've gone through these data releases more regularly, and we'll be able to give you guidance when we release this that, hey, we need to hear any single frame issues in a month, 2 months, whatever it can be. We'll know what that time frame is when we get to this. Okay. No immediate hands. So we solicited questions from the audience, from people online, on the community forum. So I just want to answer a few of these that we got, just to make sure that everyone got their answers. We did have a question that came in about heel-sparse property maps of the mask planes. I think the details here are, whoever asked this, thank you for the question, all your answers. I hope this answers your question, but we were not going to make heel-sparse maps for the mask planes. The mask planes are sort of the detailed mapping of what bits are, what pixels in the image are detected and what pixels are cosmic rays and what pixels are saturated. That's all available to you in the process visit images, and the heel-sparse property maps are more for higher level information. And we also did get another question that we kind of want to address just for anyone who's listening, and make sure that you saw Adam Bolton's talk in the image cutout section about bulk transfers. So we do have a process for supporting bulk transfers to IDACs or other data facilities. The plan is using Rusio at the moment, and we're starting to ramp that up and aiming for data preview 1 to be the time where we actually have exercised bulk transfers to other data facilities. And there's now a Slack channel that you can go to hear more about the details of that process. But really go check out Adam's talk or ask Adam more details for bulk transfers. Okay, so really that was the session that we had planned. I just will summarize saying that, like, we're always welcoming your feedback on the data products and the processing in construction and operations. We have lots of venues for this. We have lots of formal and informal channels for this. and high-level goals and low-level details. We all love to hear about all of that type of feedback. So we're hoping that these different strategies will help you give us more feedback. So thank you, and we'll do any questions. All right.
So for 9 months of
You have to shout loudly to the microphones over on this side of the room.
for the 9 months of the DRP, how much computing do you have to execute that in 9 months? Like in terms of nodes or cores or whatever is it represented?
You have to give Will like 3 minutes to go look it up. 5 minutes.
But it is just enough that if all the cores are full, that we complete data release processing in 9 months. Like it is.
I'm just curious, is it, we're talking 2,000, 20,000 or 200,000 cores? I'm interested in the scale.
I can guess, but if I guess wrong, it's going to be embarrassing. So
That's why I'm wondering.
It's about 2 laptops, Mario.
We can get back to that later.
yeah, we'll get it. We have the number. Yes, you might have to shout loudly to convey over here.
1,188
I'm
cores.
gonna walk over here, okay. I apologize for this question, because I do understand the challenges in how long it takes to process the data. And this is a somewhat desk-centric question. So, given that there's, there's not a lot of time between when you're processing the next data release and like folks being able to look at the data release before. My concern is, so for the desk static science, the uniform releases are particularly important. Right now, that's year 1 and year 10. If we do the uniform rolling, then it would be year 1, year 4, 7, 10. So if there is we find a problem with the year 1 that is such that we can't do the cosmology we want with the year 1, in this timeline, there's no room for like reprocessing that. And any updates then go into the next release, but the next release is year 2, which is not uniform. Is there, I don't think this is possible, I'm gonna ask anyway. Is there any way that then one could process year 2 such that you could then sub-select the uniform year 1 that we would want? Or are we waiting till year 4 if that's uniform for the next, you see what I'm saying? And this is partially an argument for like, can we get the data, some data to practice with and have a lot of the community look at as early as possible, please. But yeah, what would be the options in this scenario?
I think you understand the way that we're kind of trapped between a brick wall and a really heavy truck.
I do, but you understand that, yeah, so that in the
I
sense
take
of
the
like,
point.
not all releases are equal for all science.
Yeah. I think this is something that we have thought about this as a way of at least getting some of that, some handle on that. But you're right, it doesn't get nearly to the full scale of the problem.
And it won't go, yeah, so we have folks in commissioning, but that's not everybody. We won't be able to get our full community looking at the data until DP2. And your preview, and I think this is a great plan, the small preview data, but that doesn't go into effect until later. That's not there for DR2, right? I mean, that DP2 is what we have for the.
I don't know, I don't see a cost neutral solution to the brick wall and the truck. There are some, we've been told DM shall do a data release every 12 months.
Yeah.
And you only get enough money to have cores that such that if they're chugging for the full 9 months, you can complete that. And like this,
There's no way to do like 2 sets of coads, which would be the like reprocess the Y1 coads at the same time as doing the Y, because that's the problem with.
like if you can think of cost neutral solutions, like DM will entertain them. But if they're not cost neutral, then they do need to go through this resource allocation committee that we were talking about.
I think it's also worth keeping in mind that not all problems mean you have to start from scratch.
No, I
And
agree.
so it's,
agree.
there's actually a wide range of problems where if we're able to catch it early enough in the process, or if we're able to do some kind of fix up after the fact, then I think there's a good case that like we should make that type of fix up available.
Yeah, I'm coming from the DES experience where we have had to reprocess some of the stuff. I mean, some things are later on, you can like just change flags or something and you don't have to reprocess everything.
Right,
But some
right.
things do really require reprocessing.
Yeah. And we've had real experience doing the fix up, so like it's not unfamiliar to us.
Yeah.
I think it's something that we're just gonna have to manage as we go. Maybe you want to give a
comment on that.
Yeah,
Yeah, without
Adam.
putting any numbers on it or making any firm statements or commitments, for the earlier data releases, which are a smaller data volume, there may be a little bit more slack in the system to be able to iterate at some level. Because, you know, you provision things on 5-year timescales, and that imagines that eventually the data is going to grow to be as big as it is at the end of that. So early on, we may have some additional computing capacity to soak up some of that sort of back and forth.
like I think data release 1 and data release 4 actually kind of behave differently in this case. Data release 4, we've had more practice. We've also had more data through the pipeline. So hopefully we're not going to introduce terrible bugs at that point. Data release 1, like Adam was saying, there actually might be more room to fix things. I think you want, Keith, was that still on the topic or?
It was just a clarification question.
Okay, Keith.
So DR1, first 6 months of LSST observation. DR2, first 12 months. So when we say when this beta release comes out, is that the beta release for DR2 that would come out at the same time as DR1?
Let me not make a guess off the top of my head on that, and let me look at the calendar because
I think it's that DR2 based on the first year of full LSST observations. That's the one of interest.
DR2.
Okay,
We care
okay.
about DR2.
Okay, thank you for that clarification. I will make sure. we
And
get that
then
right.
getting all of the DP2 and DR1 as early as possible to, I mean, like, there will be great science that comes from that too, but
Okay.
like, you know, as early as we can get those things for
Which is
DR2 processing, that would be great.
right, and that's true that you do have the full DR1 as a precursor for doing that checking on.
But by the time we get DR1, you're not processing, I mean, there's not really much time before you start processing DR2, right? DP2,
Yeah,
you'll have some, anyway.
Yeah, let's take that offline because that's
Yeah,
a,
yeah, that's
we gotta
fine.
look at calendars and I forget exactly what the plan is in terms of processing the 6-month data. Jeremy had a question.
What are the plans around the data validation on what's coming out of the pipeline? I know there's some nice stuff shown on the pipeline session, but what would you like to have ideally, in other words, to look at how the pipeline output is changing as you're putting in, as everyone's putting in fixes and things, and like what would you like to have ideally there in terms of visibility into how the pipeline code is outputs are changing over time to the point where they're then frozen?
So all those plots that you saw in Yusra's talk and the science pipeline team's talk, those are like our primary validation tool. Like that gives us visibility on all those effects. It's not a complete set. We can always be adding more.
Yeah.
But that's like step 1 is getting those generated on the whole data set on every type of algorithm.
And what triggers the production of those, and how often are those produced? Is it based on weekly releases? Is it based on someone triggering it manually, or is it
I'm pretty sure there's a slide that you have on this
Yeah,
in
well,
the talk.
are you talking about data releases, or are you talking about like pipeline development that's going on in the background? Because
I guess I'm talking about pipeline development. I mean, and I guess you want to see for data releases as well. So,
okay,
yeah.
so the answer for those is a little bit different. For pipeline development, we're going to use subsets of LSST CAM data that are fixed and then very to show how the metrics change on those cumulative. There's also the cumulative data release productions that are coming off for the new data that's coming off the telescope. Anyway, you have fixed data sets that you vary the pipelines and see how your swapping one algorithm out for another changes your metrics.
What's the timescale for that?
Weekly. That's like, there's a weekly development cadence. And then during the data release production, so like on that diagram that we showed of the different stages that happen during production, that was actually like only partial, because that was the strip that was the USDF and didn't include the UKDF and the French DF. There's a copy of that version, I think, on the last slide of this deck. It's roughly split into stages where we do single frame processing, and while you run the single frame processing pipelines, it emits metrics and plots as it runs. And Colin's verification validation team is going to be monitoring those metrics and plots as it dumps them out. And then at the end of that stage, they will certify it and say like, yes, this is fine. And then there's going to be another little pilot run that takes all the backports with the new version of the pipeline and then runs like a little percentage throughout to the end. Then you start the next stage of the pipelines, which emits its own metrics and plots. They monitor it. At the end, they certify that, say, yes, we can move on to COAD processing, same thing for COAD processing, same thing for DIA processing, and like these are the stages of the DRP processing. But there's time to pause and reflect on the quality at each stage.
Colin, can I make it quick?
Yes.
I just wanted to clarify for everybody, this resource allocation committee, which we are actively starting to work on right now. Think of the resource allocation committee that's going to help us make merit-based choices for resources that we already have within our pool. We're talking about new resources to do something we hadn't planned or that comes up. That's going to be a larger discussion. The users committee will play an important role. I'm sure the science advisory committee and others will play important role, people inside. But those kind of discussions will eventually have to go to the agencies and us working with them to get new resources in. So the resource allocation committee help us allocate things that we already have in our plan to support users.
Other questions, clarifications, comments, opinions? Statements.
What would it take to accept a bug fix from the community?
Describe the use case.
Somebody finds we're doing something wrong and they say, it's line 27 of this file. I've written the documentation to fix it. This is the regression test you need to run. Can you merge it? As opposed to, look, this is wrong. I know how to fix it. Here's a sort of sketch or somewhere in between.
We're not going to turn down suggestions that we see the value in, right? If you point out a bug and we're like, yep, that's a bug, like the process itself is sort of immaterial at that point. We're going to make sure that it gets incorporated in the release to the extent that we could incorporate in the release if we had found it at that time. Like I was saying, there's just timescales that matter. I think all the questions depend on if we're in the kind of in-between territory where you have a hint of something and it's not clear to us if that's really a bug. And I can't think of a generalized procedure there. I think what like the slides that Leanne was talking to at the beginning, the community forum is still like the primary place to come with those types of comments and suggestions. A lot of times I expect users to not know if something is a bug or a feature or a bug or something that they just didn't quite understand correctly. And so we want those to first get channeled to community. And Pipelines is watching community science team is watching community. Like those suggestions that we see oh yeah, that's totally right. That's a good issue. We'll pick that up and make sure that it gets through the process. I think it's about as general as we can be.
So you're not expecting to be getting patches from the community. I mean, bug reports are less valuable than a fix, but a fix is more expensive for us to accept. I just wondered how you saw that continuum.
I'm not gonna turn down patches. I don't know how to be more specific there. Bill,
I think I might have heard you say that you want to invite pull requests rather than just receive. That there's this process for understanding on community the bugs, and then at the right time, a patch would be welcome. Is that fair?
Again, it's hard for me to give too, like, I don't wanna.
Yeah.
It's hard to like make a policy that covers it. I think community is the place to start because it has the lowest barrier to entry, basically. So we can get users commenting and communicating with us earlier than if they were to like wait, do a lot of debugging themselves, make a pull request, and then if we have to say like, oh, well, that wasn't quite, kind of misunderstood something, it actually would have been better to get a comment on community first. But again, if somebody makes us a brilliant pull request, awesome, like who's gonna turn that down? So I think that's about as best as I can.
The reason I asked the question is because it's been expensive taking contributions from outside DM. And I think it might be helpful to set the expectation of how we want to interact with our community, who will find problems, they'll know how to fix it. And what you're saying is, don't expect you'll file a PR, start on community and start discussing. And I guess it was that sort of level of policy I was asking about.
Yeah, I take that point, and I think that's like, that question is something that's on our to-do list to kind of write down what we expect more. We're not ready with that right now at the moment, so I can't give you generalities.
Okay.
But we will kind of make a better like roadmap for people on that type of question. Okay. Bill has a number.
I have several numbers.
Okay.
And so I think you have, well, I see that Roma and Milan together, everything has 40K cores, but then Kian, Katie is saying that we don't know.
Right, that's what's on the floor. That's a totally different topic.
So the DRP number is 7,000 cores per year. We started about 9,000 next year, and then we add 7,000 every year to take the next bit of processing. There's another 1,000 something for alerts, which we might be able to use during the daytime or something. So the first number I said was the alerts one, and that's always
like, is that 7,000 per year? Is that net of things aging out?
and then there's there's a refresh that goes on top of that to keep you getting that every year. So
okay, so for Mario, it's 7,000 plus 7 plus 7 plus 7.
Sometimes it's 8 and sometimes it's 9 as some older ones go out and replace them.
DR2.
That's 2024.
Oh yeah, that might be USD.
Like just here?
That's just here.
Right, so you gotta multiply it by French and UK count.
So DR2, which is the first one where you have full 9 months of runtime, would be 14,000 cores here.
Yes.
Times what factor for the other centers? What is that factor for the other seven?
I hit it on the slide, but it's there.
35% in France and 25% in the UK. So basically half of that at UK and a little bit more than half of that in France.
So divided by 0.4, 14,000.
Okay, while they're doing that, any last call for questions, and we'll leave the discussion for actual. Okay, Francisco, last question.
So this 7,000 is 10% in Chile?
That's correct. Chile also, I can give you the actual. For Chile, it's 103. Because Chile is DAC,
You should come up
data
with
access. We can
real
look at that.
detail.
It's 10% of the data access, which is a different number. It's not the processing number. You don't get 140,000 cores or whatever.
Okay, Leanne, did you have any last words?
No, I didn't. Sorry, it just took me a minute to find the unmute button now. No, I don't. But one thing I did write in the chat just about the whole process, the exact process to receive feedback. Ari Roberts' discussion of patches, feedback, community, etc. I agree. It's very hard to sort of write down a policy now, but I think DP2 will be very instructive in seeing how this will pan out, and will be a very good test case for us to try to develop those policies in. So I think we're all looking forward to that. But otherwise, no, thank you everyone for your advanced questions and your input and feedback on this. I think it's really important that we all try to develop a good process to work with the community on these data releases. So this is the first step. Thank you. And thanks to Colin for running the session at Slack.